I have drawn some air molecules. This is a region of air where some sound waves are traveling through, and the regions where the molecules are close together, and other regions where the molecules are further apart. This is what sound waves are like. Similar to Slinky, where here I have regions where the parts of the Slinky are close together, other regions where those parts are further apart. Now, the wavelength is the separation distance between pulses from here to here or from here to here. The speed is how fast these pulses travel through the air. The frequency is the number of pulses per second, and the relationship between frequency, wavelength, and speed is given by this equation. Speed is equal to frequency times wavelength. For example, if I have a tuning fork here that vibrates 512 times per second, I set that into vibration, and then 512 times every second that tuning fork will send out a pulse that we call a sound wave. Those pulses will travel out at a certain speed. They'll be a certain distance apart, and that's basically what sound is all about. Pulses moving along with a certain speed, at a certain wavelength, and at a certain frequency. Next, what I'd like to do is display that sound on a device we call an oscilloscope. Here I have a drawing of an oscilloscope with a signal on it, but before we put a signal on the oscilloscope, you notice that the signal is just a flat line. And what happens with the oscilloscope is we have a beam of electrons that go through a tube, and they draw a line on the face of the oscilloscope. You're looking at this line out here. I have a similar tube back here with a straight line going across. So if that beam of electrons moves along without moving up and down, just moves along with a certain speed, and then goes back, and then moves along again, it'll draw a line over itself many times. And that's the trace that you now see on the oscilloscope. But suppose I were to, as that line moves along, I also move it up and down with a certain frequency, such as the frequency of vibration of a tuning fork, for example, and I can do that electronically. If I have something moving up and down like this, but not moving along, it'll draw that kind of a path. If it moves along without moving up and down, it'll draw that kind of a path. But suppose it moves up and down and moves along at the same time, then what it'll do